Hello, everyone. I would like to welcome everyone to our new product showcase presentation, detailed landmark high performance windows for approval. I would like to welcome Zola, and thanks for your presentation today and for your support of New York Passive House as a sponsor. It's a pleasure to have you as such a strong partner. I would like to introduce Jose, who will introduce today's presenters.
New York City's client support for Zola Windows. Just a short intro for Sam. Sam is in charge of Zola's New York City client support and market development and has launched the New York City Low Carbon Building Social Networking Group, focused on expanding the reach of high performance buildings. I personally have been attending some of those meetings the past year when we could have. And it's really good to see everyone coming together. Thank you, Sam. He has been a student of green building ever since buying his first Airship books back in 1988. And since then, he has received an MFA in sculpture from UC Berkeley. With that, I'd like to give the floor to Sam and take it away with the presentation.
Thanks, Jose. Thanks, Andreas. Hi, everybody. I see some familiar names. It's great to see the community out in this weather. I'm a 20-year Passive House, not quite 20, maybe 10-year Passive House in New York, part of the beginning of the movement. And it's been exciting to see the growth in the landmark, which is my love. I love old buildings. I love the New York landscape, but to see them being transformed to high performance is truly amazing. So today, I'm going to share with you learning that has taken place over the last about 10 years as interacting with the Landmark Commission and the Passive House type buildings. And then we'll have a lot of questions afterwards, and I'm happy to stick around as long as I need to provide you guys with whatever answers you need for your projects. So let me get started giving the presentation. I'm a fenestration consultant focused very deeply on historic buildings because I am an ex-contractor, ex-landmark contractor who built one of the first passive houses in New York City, completed in 2011 in Brooklyn Heights. So with that, it's all been about preserving these beautiful buildings and getting the performance, the passive house, the details, the pricing, the budgeting, and also training tradesmen as well as architects on how to use these beautiful windows and how to transform these old beautiful buildings to high performance future construction. Overview of the objectives is to talk mostly about design and to understand a little bit about why you might be wanting to implement new windows versus replace the windows versus renovating the existing windows, and to understand a couple of the different types of historic, and then also just the long-term and the performance aspects of the buildings, the dramatic change that it makes. Is replacing windows versus repairing the original is kind of a debate that goes back and forth. The traditional approach of let the building breathe versus passive house. It's nice to see that there's an education and movement in the community towards understanding how these old buildings work better and better, the building science behind it. So people do understand the most important aspects here at the bottom is that draft stack effect in old buildings has an impact on the structure integrity of old buildings. So the more humidity in these changing conditions of old buildings where we have steam showers and air conditioners in the summer, the more movement of air you have through the building, the more that moisture makes its way towards a dew point and can actually cause damage in the upper portions of the building. You see this when you actually start to take apart the old buildings and you see mortar damage and the top 4 or 5 feet of the walls starting to fall apart, and you might think that it might be just rain damage, but actually it has to do with moisture as well, moving up and through the house and finding those cold surfaces during winter, condensing on that brick, condensing on those joist pockets, and actually starting to degrade it over a long period of time. So our wet interior environments need to be more controlled. So as you shut down the stack effect in old buildings, you actually prolong the life of the building as well, not as well as reducing its energy usage, as well as creating a higher level of interior comfort for its occupants as well. There's a couple types of historic windows. A lot of people just talk to me about historic double hungs or simulated double hungs, but we also start to talk about French operable casements, both in swing and out swing. Uh, we have both of these are actually completed projects that you're looking at. So we do both casements and also hung. Casements are much more difficult because the lines are much thinner, and it's hard to work performance into the thin glass to glass lines. But I also get across my desk a lot of steel replacement and some mid-century modern, which are very complicated to try to retrofit to high performance depending on where they're located and what the passive house design criteria is for the outside conditions. So what are the key aspects of what historic commissions, or what are the key aspects of the conversations over the last decade I've been having with historic commissions on what they're looking for and how we design our windows to match what they're wanting to see. The five are if you've done passive house in historic, or if you've done any historic windows, it's pretty obvious. But the key is not just the glass relationship to the opening and how much the percentage of the area is, but the design lines and any of the glass to glass relationships for frame that actually crosses through the opening. It's kind of like the historic casement windows. What is the glass to glass for those? And then also the horizontal bars for the simulated double hungs. The most difficult one is requirements for operation match. Zola doesn't make a double hung window. And in my time doing passive house, I haven't found a double hung window that actually could provide passive house air tightness. I did come across a German double hung window that had these amazing inflating gaskets, and their price was 4 times that of a Zola double hung window, and its thermal performance was about 20% less. So yeah, I think out there, if people want to be pure and to replace a double hung with a double hung and try to get high performance, you probably could go find a bespoke product somewhere, but you're going to be paying a huge premium. So we're going to be speaking mostly about simulated double hungs and also our version of casements, because I haven't seen on the market any actual one-for-one double hungs that actually can reach passive house for the Northeast. Step one, with any replacement, is of course assessing the rough openings for a project. But when it comes to a landmark building, the actual more important aspect is to actually locate the glass edges within that opening, because the Landmark Commission is looking to actually keep with the fabric and balance of the facade for the original intent. So that means matching the glass percentages and locating the glass percentages within their actual openings. It's not so complicated, but it is actually, this is an existing condition of single pane glass submitted to me. This is actually my background. This building is actually, this is the section that was submitted. So it's a big project, White Street, and this was given to me and they're like, can you match this? And it's like, at first you look at it and you're like 1 1/4, 5/8, 2 3/4. This is actually an iron building. So the cross hatching of the structure, there is literally physically iron window to window. There's a post, and so there's almost no wall. It's an actual steel iron building. So it was a very tight condition. But ultimately, once we started to look at what the glass edges were in relationship to the exterior opening, we actually realized that our window did in fact fit exactly where within an eighth of where they wanted to be, without having to make modifications to our unit. And so after looking, I'll just say, after going through maybe a couple hundred or more landmark projects and doing the same process over and over, there's never been a case where we couldn't fit or match the glass exterior opening relationship. So the reason is because actually traditional windows have a weight pocket embedded in the wall, which causes this very thick 2 3/4 to 5/8 plus 5/8, this very thick cavity that is required. So replacement windows from like the 1960s and on don't they had spring balances, and they have other methods to actually hold the weight of the glass when you're lifting the window. But traditional windows have the weight pockets, which we take advantage of in actually implementing the high performance aspects. So one thing I do want to point out between the existing single glazed and the triple high performance passive house replacement is that actually the interior finish line does change. It does move outward away from the glass. So even though on the outside you do have a very close relationship match to what the existing condition is, you will need more space on the inside when it comes to finish returns. That actually often is the most problematic part of a project, especially where they're wanting to keep the interior louvers. If there's a opening louver with pockets, oftentimes they want to keep and not renovate or install new louvers. But what happens is, in fact, you have a new interior finish dimension, and those actual panels no longer fit, or it's very precise. It actually takes a lot of design work down to the eighths of an inch to get that to work. So there is a lot more design work to look at on the inside. The next item is, of course, shadow lines, and that is the aesthetic step back and the lines as they move from the opening back towards the glass. And on the left, you can see that there's a 2 3/4 by 1 3/4 brick mold with a 5/8. And as those steps take place, landmark commissions and replacement windows, they want to see these same like cake layers as it moves back to the glass. So for the brick mold and the simulated rail system that we install on the right into our simulated double hung, we can definitely match brick molds and reveals or get very close to it. You can see that they have a 5/8 on the left, but we have a 3/4 from our back. We can start to match those as they step back, but the actual physical window and the actual glass reveals, we're much more limited in what we can do with the actual operable portion of the frame versus what we apply to it to simulate the actual historic. But you can see from what we've done here, you can get extremely close, and actually the finished conditions from the street level are almost imperceptible. Meeting rail and the crossbars or vertical bars with casements, those are actually much more difficult. So we get a lot of windows that come our way, and they're telling us that the wood piece is 1 inch, and the glazing bead is 1/4 on each, and so we're getting 1 1/4, 1 1/2 inch, or 1 5/8, and these are usually often huge windows. So to start off with, historic windows often have used a much higher quality wood than what we have available to us today, a much more stable, a stronger, a tighter grain, old growth. We're actually not able to work with those type of materials currently. There's just not a lot of those type of trees left. And so the structural aspects of the material we're using requires us to actually include more wood. Otherwise, we don't have longevity, we have warpage, and we have movement. So we actually, I'm gonna move my screen here. So you can see, even though on the left they say 1 1/4, it's actually more like 1 5/8, because I think it's about, or not, about 1 5/8 because of the bottom piece included for the glass. So we're more than that, but we're not too far off. And so this is one place where the glass percentage gets impacted. So we actually do have a slightly larger median rail when it comes to our simulated double hung, but it does stay within the 5% of existing, or 5% of the original glass percentage that they're looking for. And in all cases, the detail on the right has been accepted by landmark commissions for all projects. We've never actually run into a problem with getting this cleared with New York City or any other region. So operation match is really kind of a hang up on some projects. Wanting to keep with the double hungs, wanting to actually make them more pure. I always pull up this picture that I did in 2011. It's just as good today. And the question is, which one is the simulated double hung? They're all Georgian style, very tall, same height, same street, same era, Brooklyn historics. And it's only the one on the left that is a simulated double hung. It's actually a passive house too. So the one on the left is a triple. It's a fixed over a tilt turn. The other ones are all double hungs from different manufacturers. So even though there was lots of debate about would it look right, how does it feel, what is the case, the only thing that I could tell about the one on the left was that the crossbar, the meeting rail, was thicker. And so actually this meeting rail is like version 1. And what I just showed you with the last couple slides with it tucked up behind and smaller is actually our third version. It's physically an inch smaller than this one. So when people can't imagine the operation, of course, the top is fixed and the bottom is a tilt turn. So if it's in the tilt or if it's in the turn, it has a different feel than if it's a hung like the other three. But actually, the preference for the tilt on the left is pretty strong because in fact it actually gives better ventilation and overall these windows are much more acoustically tight as well. So the fact that these other three windows let in a lot of sound, that usually is why people end up going with a historic simulated double hung because of the acoustic as well as the thermal and air tightness. Here's a couple examples of actual interior installs and retrofits of historic landmark buildings and a couple approaches to how they handled stained glass. So this is this window that you're looking at, the stained glass window, is the original window that was installed in this project. It was removed and restored, and then we actually aligned and designed a triple tilt turn system that was mounted into this opening. And then the original window was reinstalled just inside our triple. So these original casements actually are in-swing casements with Tiffany glass, and then they can actually then get to the exterior triple window and tilt it out if they ever wanted to open for ventilation. But this is actually a double window install because we couldn't install this amazingly historic glass into our units, and instead they built a window in front of a window to achieve this effect. The alternative is to take the existing stainless glass and integrate it into our window. We had a couple projects where we packed up the stainless glass and shipped it to our factory and put it in the middle glazing and integrated it and then installed it into the window. And it was really a nightmare, and it didn't really work schedule. It just took a long time to ship stainless glass with the risk of breaking it. Yeah, not stainless, but stained glass with the risk of breaking it all the way to Europe to our factory. So we actually have taken this approach since then, which is to detail. And so when we ship the window, we've sized the actual stained glass stained glass location to actually be the existing glass dimensions, and the customer or our installer then removes the bead, removes the glass, and either installs it on the inside or the outside. I always recommend that the stained glass be installed to the inside of the triple because of the water tightness with the exterior frame. But in this case, this client really wanted to have it on the outside. So they pulled the glass, they put it on the outside, they put a spacer, they recaulked it in, they made sure that their stained glass was watertight and had it restored, and then reinstalled it. And here it is on the right. You could see the triple reflection in the lower two windows, throwing that tree reflection like a fractal. And then, of course, the stained glass that is mounted proud in this historic landmark. And I want to add that this detail even still maintains the air tightness, and this is a certified passive house. So, and then a casement situation, French. This is an outswing casement to passive measures, and the original conditions showed a glass to glass at the meeting rail, which is the most difficult condition of a 5.5 when it includes the glazing beads. We were able to actually get a better condition, but it had to be dual glazed, which is not passive house for this location. We could not solve this in a triple glazed situation. So that's why this is passive measures, and this project can't go passive house because there were so many situations on this that are historically precise, and we were unable to actually install the triple glass in this location where the rest of the house did get triple glass. These French casements had to get dual glazed glass with double gaskets. So you can't really actually solve all historic problems to pure passive house measures is what we found. And that goes the same with steel windows. We get a lot of requests for steel windows. And the problem is that steel windows often come with a very, very thin, this is an aluminum window image, but we often get an operable to operable casement of like 2 inch to 2¼ inch, a request that can you match these steel dimensions? The answer is yes, you can match it if you build another steel window, but the moment you start to put thermal isolators into the frame, the steel window starts to get thicker. And if you actually are trying to do performance or near passive house, what you find is that a steel window with the thermal couplers inside the frame, they start to approach aluminum window dimensions. And at that point, the cost of steel, which is like 2 or 3x that of aluminum, makes no sense if you're trying to hold dimension. And so the dilemma with a steel window that has like a 1 inch frame with a little bezel and micro, and by the way, no gaskets or anything, and a single pane of glass, is that when you go to replace those, it's got to probably be replaced with a much more robust window that actually can fit a gasket, can actually have some thermal decouplers in the frame, and can have at least dual, if not triple, for New York City. That doesn't fit into 2.5 inches. This detail I have here is one of the thinnest aluminum frames on the market. You can see on the right that the fixed version is 1¼ inch outside dimension to glass, but the operable version is 3 1/8. And if I even bring fixed to, it's 3 3/4 minimum to do an operable to a fixed. An operable to an operable is much bigger. So steel retrofits and the operable dimensions are really problematic. And I actually have gotten dozens of projects across my desk, but have not been able to source one that fit a budget and solve their problem and also could do high performance to date yet. I do know there's a lot of steel product out there, and I have sourced dozens of different frames. And as we price them out and we look at the dimensions, we realize that aluminum is almost the exact same dimension with higher performance at much less price. And that's where the market starts to shift back to aluminum. So I just want to make you aware that steel solutions are very hard to find. So. And part of that problem is thin versus thick. So there are demands for very thin frames and little tiny dimensions that have no insulation and very little structure. And if we're to make long lasting windows of high performance with insulation, then we have to go thick. And our default passive house glass for New York City is a 48mm triple R11. And often that nearly 2 inches of glass is thicker than the actual window frame we're replacing. So to implement performance, let me just talk about glass for a second. For those who don't understand necessarily what are thin triples, what are thick triples, why the performance, why can't you fit R11 and R15 into a thin, where's vacuum glass? Like there's a whole lot of items out there. If for an argon glass, dual 5.26 versus triple, which is an R11, you need about a 16 to 18mm for argon to be optimal. If you go below that, then your argon's performance starts to degrade and the performance of the window degrades and it starts to get too thin, and at which point you need to actually upgrade to a krypton gas. Krypton gas is better in thin spaces. Argon is better in thicker spaces. And so as you get thinner, you certainly could increase your performance by actually switching gases and increasing the noble gases, but your prices go up quickly for the glass. So if you can fit the higher performance 48mm glass into your window and design around that, then you get the best performance at the best price to match the design. And that's the sweet spot that we work in with high performance passive house. With those dimensions, there are just some thin situations that we are completely unable to solve, unfortunately. And it's because, like this window on the left, I think that's probably less than 1 inch for that glass to glass. It was just so micro thin. It was, ultimately this can't be in an offset. This has to be a single unit that actually is like a tilt or a hopper or casement. I've actually never seen this situation again. This is the only one of this I've seen. So, all right, and coming into conclusion, performance. I've sat and watched so many performance presentations when it comes to Passive House. But ultimately, it comes down to one thing when it comes to implementing performance or getting a higher quality window. And that's that it's airtight. A dual glazed airtight or triple glazed airtight, it doesn't matter. So that's one of the biggest reasons why high performance buildings have to high performance historic buildings have to transfer away from the actual double hung is because double hung windows are not airtight. And so the biggest component of a building efficiency is reconditioning incoming exterior air and the loss of the conditioned air out through the shell. And that cycle of that air moving in and through and out and the amount of energy it takes to actually recondition that space. Once you implement air tightness, which is the key component of Passive House, once you do that air tightness, you actually start to see dramatic gains in the building efficiency, regardless of the U value. Thermal bypass is shut down and all these other things. So a lot of people come to us and talk about U value, what's your U value, what's your U value? And I'm like, our U value is this, which is appropriate. But by the way, at least buy a dual glazed airtight. If you can't, at least buy a triple. Do at least implement air tightness because that impact on your project is going to be immense by itself. Choosing to like go with a equivalent or slightly less U value in a window that doesn't have air tightness, a double hung and or crank casement without multiple glazings, multiple gaskets and multi-point lock system, it's going to really impact the interior comfort of the building as well as the thermal performance and efficiency. And so that in and of itself is the biggest thing. And so I'm leaving this, that's the end. That's I have a worksheet I'll show you just after that, but I kept it short and sweet because I actually think that answering direct questions is really key, especially in this project by project, because there are not 1, 2, or 3, or 4 types of historic project. Each project in and of itself has its own kind of really specific details. But what I wanted to also show you is a worksheet that we've created to help you work through your opening detail and to help you understand how historic or simulated double hungs can fit into it. Let me switch screens real quick. So I have created a worksheet that I work with because people always ask me over and over to do the same task. And so when I get the same request, I start to make them a shortcut to do it. Take control. See if I can zoom in on this. Hold on a second. All right. So the first step in actually establishing the window and the opening, as I said before, was figuring out where the glass edge relationship is to your opening. And here in this center upper fixed horizontal section, what I've done is I've actually zeroed out the face of the frame and the glass edge as your datum starting point. And so if you take your existing condition and measure your glass to your existing masonry opening or exterior opening, you can then take this tool and measure back away and start to make that line and get an immediate reference for how our frame fits your existing condition. What's usually the case is that we're sitting probably 1/4 to 1/2 inch just behind your masonry here in New York City for almost every single situation. So our frame is probably about, like I said, 1/4 to 1/2 inch wider or prouder than your masonry opening and exterior condition is, which puts us slightly into the shade pocket. Oh, I couldn't see it. You could see it, but I couldn't see it. Sorry about that. So you can see I've actually inserted it. And this person, which is a recent project, was actually looking to fib a little bit and wanted to get a little bit more glass and kept squeezing me. So they said, please make it 1 inch. And I was like, yes, but it's 1/4 inch. You know that, right? And he's like, yeah, just draw this 1 inch. But I just want to point out that once you establish the masonry opening of the exterior condition, you then can establish the brick mold, the spacing, and the shadow lines leading back to the glass. And in nearly every case, you get extremely close to existing condition for historic windows in the double hung configuration there. And you can see here on the left, the head vertical, their condition is actually 13/16 larger than what we have. So there's plenty of space there. And that brick mold then comes up and covers that as well. But if you ever needed some assistance when it actually comes to working out, we have this quick worksheet that actually we can throw your dimensions onto our window, so you can get a feel for uh, your historic conditions need to fit to achieve high performance passivhaus. And with that, short and sweet, I'll open it up to questions if you have any.
Thanks, Sam.
Sam,
Sure.
for presenting. Very interesting. Yes, Jose will take some of the questions out of the chat box. I was just wondering, so you guys have an approved landmark window, correct?
We have a simulated double hung that is staff level with the Landmark Commission in New York City. I guess that means approved, but I'm careful not to say approved or not approved. It does. You always need review. So, but it is staff level at this point.
So whenever someone makes a change in the window profile, you would have to go back to the staff level to get that approved again, or?
Our window dimensions are pretty fixed for Landmark, and so there's no modification from us. It's more for them. If they're going to make a retrofit and replace the window, of course they're going to need to make a submission for approval, and the architect sets up their meeting. That's not something that we go to, but we provide full support. That's what this detailed drawing sheet is to really kind of just assist the architect to say, look, these are the details. I've done this. I've seen this 100 times. So here it is. Here's some examples of a submission. I have a couple submission examples that I do share with architects who haven't gone through the process before, so they can see the details and sections and kind of get a jump start and go straight in. So
cool. So Jose, take some of the questions.
Right. Yeah, we have a couple minutes. So our first question comes from Luis Arturo Corso, and he's asking, have you ever considered using VIG instead of triple glazed?
Thanks for
yes. So I was unable to unmute myself, so I apologize for that.
That's okay.
So yes, that's what I meant. Vacuum insulated glass that came up a couple of weeks ago, where we were looking at different options for windows on a project we're working on, and the sales rep was mentioning the VIG glass, and he said, listen, it's extremely thin. The only downside is that when you look at it up close, you're going to see certain elements that may pop up, but other
lots
than
of
that,
lots of little trees, little dimples in between the glass.
Yes. But it was great because you have a very thin glass and you meet the energy performance.
What's the price?
Yeah.
What was the price implications? 4x, 5x?
A little bit more expensive, yes.
Yeah,
probably 4x.
And then the warranty on the vacuum was how long? They couldn't warranty it, right? So
we didn't get to that point. But
those are the two pieces. One is there's a very small supply chain. Two is it does need little spacers to keep the glass from collapsing against each other.
Mm-hmm.
The third is maintaining the vacuum over a long time. And I think that's the unknown in the market. It's so expensive and no one's really sure if it's going to keep its vacuum. And there's a bunch of places in China that are trying to bring it through. And there's a bunch of places in Europe that are trying to bring it through. I think the success with vacuum insulated anything is in the foil VIP panels, vacuum insulated panels that seem to actually be taking off. But even then, those products are extremely expensive. So
right.
If there's no budget, sure, we'll explore it for you. But ultimately, there always is a budget.
No, absolutely. And one problem that we hope is solved in the near future is thicknesses, right? Both for windows and for roofs, and everything is just getting extremely thick because we're not there as far as technology is concerned to meet the requirements that are being set forth. So
yes, thicknesses are crazy. Yes, of course, with passivhaus. So there are two parts to the window that actually require a little bit more frame thickness. The multi-point hardware that actually causes the frames to be nice and tight when they're closed, that needs space to be installed. And so, I mean, our market is driven by manufacturers. So unless somebody comes up with a brand new hardware system that everybody adopts and everybody comes up with vacuum panels, those two things are not going to be implemented very quickly. We're going to be on the standard 30 to 40-year-old European system, which is what all this is built on. So Otherwise, you're going to get bespoke and very expensive windows, which are not going to sell to most projects.
So Jane asks, can you make a simulated double hung window in aluminum clad wood? And has Landmarks accepted this on any project?
So not only us, but there are no manufacturers on the market who do a simulated double hung aluminum clad, which is wood with a clad on the outside. The best I can tell is that designs are still iterating, and each manufacturer has a slightly different design for how they do it. And no one has committed to extruding the 600-meter length of aluminum parts that are needed to do these custom windows. The volume and market of this is just so small. So those are the actual core reasons financially why nobody's committed to like actually a clad window. Also, when you do a clad window, you have to provide some back venting between the clad and the wood. And so you're reducing the amount of wood that's actually in the actual frame by replacing the clad, because we're trying to hold outside dimensions for Landmark. And so removing the structural component of the window while actually trying to hold an outside dimension for Landmark in that crossbar, it doesn't quite work. You're going to actually have a slightly thicker window because you do need that much material spanning those like meeting rails. So I don't know of anybody who's working on one, and we're not developing a clad version because of those design.
So next question is from Eric Hammerberg. It appears to me that your meeting rail dimension is much heavier than traditional wood, about 2 times. I'm afraid this would look very heavy. What is the lifespan of your IGU seals?
2 questions. So we are heavier, but once they're installed, sorry, I should back up. For regular size to larger windows, it doesn't even feel any different. For smaller windows, it does feel heavier, both on the inside and the outside. I'll be full transparent about it. They're not thin. It's not like these little 1 and 1.5 inch little rails that you might get on a double hung window traditional. The meeting rail that we have is usually within 5/8 to 3/4 inch of design criteria for existing for most projects we look at. There are a few projects that come through that are super thin, and honestly, that's the reason they're replacing the window, is because that's failing. I got to put it out there. The window is so thin and it no longer works. So you kind of got to balance a window that has long-term stability and functionality with a window that can be airtight and has stability and has structure. There is a breakpoint design, and we see a lot of historic windows come through that don't even meet half the criteria, but are considered like landmarks. So there has to be a give or take to the structure. You can't just do really thin pieces of wood and think that they're going to last a long time. The IGUs, argon, the sealants. So interestingly enough, in Europe, they actually test argon leakage, and it's got to be rated at less than 1% per year. And that has been, often they pull the IGUs from Windows and test it, and it actually performs better than that. That same test doesn't exist anywhere in the United States that I'm aware of. So.
Nate Croney, are there acoustic STC tests reports for the typical New York City 48 millimeter argon triple glazing?
Yes.
Yeah.
So I do a lot of historic retrofits simply because of acoustic. We design glass for BQE facing, subway system facing, down the block from an ambulatory bus. We see projects like that a lot. So I've actually done sound recordings and programmed glass and laminates and figured out what frequencies need to be targeted and inserted those. And we do a lot of acoustic testing, and we do OITC. And so what I want to point out is that the standard like dual glazed, I'm not going to use other brand names per se and target anyone specifically, but something that has a track in it that's just a moderate residential double hung has like an OITC acoustic rating of somewhere in the 15 to 17. Our simulated double hung triple has a base OITC of about 25 to 27, and OITC is a doubling every three numbers. So 17 to 20, 20 is twice as good as 17, if that makes sense. And then 23 is twice as good as 20. And so it's algorithmic increase on the OITC. And so the difference between 25 to 27 and 17 is a doubling three and a half times. So we then can actually specify acoustic glazings as well and take our windows all the way up into the 33 and 35 OITC, which are extremely quiet. So our windows are already quiet because they're airtight, multi-gasketed, so sound doesn't travel through air channels. They have acoustic considerations and spacers and triple glass, and they also use low iron glass, which is about 16% better at acoustic stoppage right off the bat as well. And so by default, the windows are superior acoustically, plus we can take them much farther.
Here's a good one. Could you show a picture of double hungs opened?
Room with 3 double hungs, 1 in the tilt, or 2 in the tilt, 1 in the turn. Did you want it from the outside? This is the inside. I can go find an outside version, but it might take me like 5 minutes to find that image. So
that's okay.
This is the first. This project is actually the first landmarked and/or the first passive house in Manhattan. That's what this project is.
So are these operating like?
Say it again, Michael.
These operate like typical tilt and turns.
This is a fixed over and offset tilt and turn.
Okay, but the middle one that's swinging, that swings open normally so you can clean the outside like a.
So yes, so the 3 ways we configure this is tilt first and then turn, and in most cases now we actually have a turn limiter that comes with it. In this case, they actually had locks on the handles. So the actual turn was locked out. All they could do was access the tilt, and they had to use a key to get to the turn.
Okay, yeah, that makes sense.
The way we often configure that is a tilt first. So the first handle location is in fact the tilt location, and the second handle location is a turn location. So additionally, we do hidden hinges. So the only hardware that's visible is the handle, and the windows can open to 90 degrees, and there's no actual hinges that you have to like navigate the trim with and stuff like that when you return it.
It looks like they're easier to operate than traditional double hungs, frankly.
Very easy, and we actually have screen systems for the lower operable portion, so you actually can have bug screens as well.
Okay, so you answered my second question, which is a few down the line.
Yeah. All right. So this one from Ben Brown, I think it's a good one to discuss, I guess. What was your comment on the performance of Argon versus Krypton? Why is it better to use Krypton in smaller airspace? And Drake Shine commented on it below, but I mean, I guess it would be good to have some conversation about it. That's an important one that I think a lot of people don't notice or don't understand in terms of, this is my question, I guess, in terms of the economical piece of it, why it makes sense to look at all the Argon versions before just going to Krypton.
So Krypton is much more expensive than Argon.
Mm-hmm.
And Argon is readily available, and there's tanks on trucks, and every factory has it, and it's the standard default gas. The actual difference between them and why do they act that way, it's just purely scientific testing and lots of graphs about air versus Argon versus Krypton versus Xenon and how they operate in different spacers. I wish I had it at my fingertips to pull up this beautiful graph that shows this. I don't have it right now with me, but there are plenty of tests that are run with our glazing partners to identify the optimal gas space, meaning spacer and the gas, because why would we do a 20 millimeter Argon when we know it only has a 1% performance increase over 16 millimeter or 18 millimeter? And so this type of economic and or assemblies and analyzing which gas for which situation is exactly what drives the type of glass that we design into the windows and the frames that we design around that glass. So it's not through lack of information, I should say, but it's a big conversation. my email's on there. I'd be happy to share with you the graph if you want to follow up, sam@zolawindows.com. It's not private information. I just have to track it down for you, and you can see for yourself the research of low E versus non-low E on air, argon, and krypton on different spacer dimensions. It's a beautiful graph I have I can send to you. So.
And we'll send out your contact info so you can follow up with the
Okay. Yeah, happy to share anything that I've shown or anything or support for anything that I've said if anybody needs it.
Can you make a double hung window that is 10 feet high by 4 feet wide? I guess a simulated double hung.
So yeah, my background, the image you see, and I can pull up some other images of that as well. Those are 10.6 tall by 5.2 wide, and they are tilt only triples. They cannot be turned because of their beam length. And in fact, if Linda's on here, pin her image. That's an interior view of the same project. That's actually a 9.5 or 10 foot tall window by 5'2" wide as well that she has in her background. So, so yes, we can. But those windows, and I want to say the iron buildings down in like Broadway and Lower Manhattan, they do have to be tilt only. We can't do a turn because there is no hinge that can take that kind of weight. So.
Can you incorporate insect screens in your simulated double hung from Michael?
Yeah, bug screens?
Yeah.
Yes, 100% everywhere. We do it almost on every project.
Yeah, from Paul Castrucci. Can you show caulking an air seal in less detail sheet you presented?
Caulking an
I
air
guess it's
seal.
the example sheet you had.
Yes, I'm going to actually show something a little bit different real quick, which is a sequential document that I created to talk about installing, which this is better. This is better. Sharing now. So I can also provide this. This is a step-by-step installation sequence for historic window in a Passivhaus with a shade pocket actually too. So. This was created for a couple projects to help coordinate the teams, because what this is 4 or 5 subs or 4 or 5 teams that needed to integrate back and forth who did what to prepare for every opening. And so I'll send this to you, Paul, so that way you can use it or have it and or revise it and or tell me what I got wrong. This is an older one. I think it needs a slight update because there's a couple different install approaches. So.
And then one from Reed Rowland's size limitation on the vacuum insulated glass.
Size limitation on vacuum insulated glass?
Yes. Mm-hmm.
We don't have any suppliers of vacuum insulated glass. People request it, we've priced it, they reject it. It's so expensive, and there's just this unknown to it. So we haven't distributed. I haven't done a project with it, and so.
Have you done a unit where there is a single pane on the exterior, then a cavity space for an integrated shade or not, and then the actual triple pane glass within a single unit?
Yeah, we do not do that product, but that product is available from a lot of other European manufacturers. The glass is actually integrated into the cladding area. And in fact, that has different types of venting because what this does is this allows for that heat gain to be trapped in that cavity just behind the glass. And in the wintertime, you could use it venting to the inside, or when it's heated up and you want to have it for the heating on the inside, you can vent it to the inside. But in the summertime, when you don't want it, you can vent it to the outside. I've seen plenty of those. They're very popular in Germany and Northern Europe. But we, as Zolo, we rarely get that request. And I don't know of anybody who's distributing that window in the United States, unfortunately.
What is the U value for the simulated triple glazed double hung?
The U value for the simulated triple glazed is in the, I should know this off the top of my head, but I don't. The glass is R11, the frame is in the 5. It's like in the R7-ish, R6, 7-ish. I can send you the spec sheets on it. Unfortunately, I don't have it memorized because I'm dealing with like 20 products at a time, and I don't have my performance table open. But I have spec sheets that I can send you, and we can also do, I can actually do some math and performance for specific sizes to help you with that as well.
How important is the actual window unit versus the installation for sound reduction?
Yeah, that's a good question. Definitely a non-airtight and a non-thermally tight, and then of course doesn't have the mass glass. If you don't install the window that can stop the sound into the opening, then of course the window is the most important. But of course, if you take a nice window and then don't install it properly, you're going to get sound going around it. So uh, what we found, interestingly enough, in most passive houses that I've been a designer for, is that we were able to easily, without even doing modifications to the window, to stop the sound transfer or completely remove it from the equation when it comes to passive house from the exterior. And it then became tracking sounds and also inside the house. I think my first passive house in Brooklyn Heights back in 2010, I remember being the last one on the job site and closing up for the night. And I heard noises 2 stories up, and I went up to find out that the window handle hadn't been engaged because the interior environment, without mechanical systems running or any appliances or anything, was so quiet that I actually heard street noise from 2 stories down. And literally the window handle wasn't shut. It wasn't that the window was open, it was that the window wasn't sealed tight. And so I think your perception changes once you start to use an acoustically tight window, as well as installing it properly with enough insulation, that it actually, the sound focus changes from through the wall and it changes to like the actual interior environment. You start to hear your air conditioners, you start to hear the water pipes in the walls, you start to hear people further away downstairs. So it changes your space dramatically.
Yeah, that's very true. And an installation between window and roof opening, I mean, yeah, you have to make it airtight, period. I mean, that's the only way to really engage in good sound reduction, regardless
Airtight.
of, I guess, the type of unit.
Airtight and fully packed with insulation. That's really key too.
Yeah.
There can't be any cavity in because there's something called thermal bypass. If air is allowed to circulate adjacent to your window, then you're going to have a really degraded U value for the window, and you're also going to have moisture buildup and damage happening in that circulation. So you need to stop the circulation in your insulation layer in all cases: the window install, your wall, your ceiling, your floor, everywhere.
Hammarberg, I don't see perimeter waterproofing on your window installation process.
Let me reshare it. We have a pan and an option to actually, so it's step 3. We have a pan in this case, but we don't necessarily have perimeter. So there is no house wrap or any other detail for this. This was actually an open drainage, but it is actually the exterior caulk and or the pan. So yeah, I do need to upgrade that. Thank you for the catch. I'll put a detail that actually puts side pans, side membrane. The detail that we use right now is to actually carry all of our material from the brick to the actual plywood buck on the inside. And that is the pan. The really difficult part is the head of the window. Most leaks don't happen through, how do I say this? I'll back up and say it again. If the brick above the window is leaking water into the wall, that water is coming down in the wall to the top of our window. And if that is waterproofed, that's really just moving the water around the waterproof and down to the next level, and on down and on down and on down. And the question is, at what point does that get captured and moved back out? And if you have it completely sealed, then it never makes it there. And really, it's a debate about, should the head of the window have waterproofing on it, so therefore the water does make it into this cavity and then can possibly move down to the sill and out? And then that comes up to the second point is, do you caulk under your sill or not? Because where's the water going to escape if you waterproof your window and there's a leak? And so this is like a 2-hour presentation and a discussion about the path of water in the wall, water behind the brick mold, water making it to the pan, water making it around the window. Because most leaks we see don't have anything to do with our window. It has to do with the install and the wall around. And so those paths and that water from the wall, around the window, and back out are critical. So that is true. This does not have that exact flashing install, but also I've seen it done about 2 or 3 dozen different ways, and I actually think that there's best methodologies for different installation systems, and there is no one size fits all in that case. So, but I will revise it to include that in step 3, just because I don't want to be embarrassed next time.
If you equip a tilt and turn with insect screens for the operable sash, how is that removed to wash the fixed upper sash on the exterior?
All of the screens are installed from the inside. There's a series of clips around the perimeter that wrap around the outermost gasket. And so they're very easily installed by just a little holding it in place, dropping it down, turn a couple buckles, it's in. The same is for pulling the screens back out for washing and cleaning the windows as well. I frequently pull the screens out of my previous tilt turns and wash them in the bathtub with the shower wand twice a year, because New York City is kind of gross. So.
Exactly, it's important to be able to wash those screens, of course.
Yeah.
So I would like to thank everyone for joining us today. I hope it was a good presentation. Thanks to Sam for presenting and Zola. Thanks Jose for helping with the Q&A and the introduction. And we will send you guys the recording probably by tomorrow. So
thanks everyone. Hope this was helpful.
Bye everyone. Have a good day.
Bye-bye.